Hey guys, welcome back to third lecture. So in the previous lectures, I have discussed the basic definitions of permutation and combination, and we have discussed the fundamental theorem of counting, and we have discussed what is permutation, combination, and linear permutation and circular permutation, the definitions. Okay, so in this lecture we are going to go further into linear permutation. Okay, so when n and r are positive integers and r is less than or equal to n, the permutation of n dissimilar things taken r at a time. Okay, so what he's saying is there are n things, out of which we have to choose r things, and already the condition is given is r less than or equal to n. So maximum we can choose n things out of n things. So this r shouldn't be greater than n because we can't choose more things out of less things. That's right. Okay, so n things we have to choose r things out of them. So if you recall what is the fundamental theorem of counting, suppose there was a work 1 and there were m1 ways of doing it, and there was a work 2 and it has m2 ways of doing, and work 3 which had m3 ways of doing. So if we were to do the work 1, after that the work 2, after that the work 3, one after the other, then there will be m1 into m2 into m3 ways of doing this. So this is what the fundamental theorem of counting states. Okay, so we are going to use the fundamental theorem of counting here to prove this expression. Suppose there are totally there are n elements, out of which we are choosing r. Okay, so we need to choose r elements. Suppose we have taken r empty boxes like this. Okay, so the total number of boxes is r times, that is r boxes are there. So out of the n elements, there are n options for us to fill the first box. Okay, and after filling the first box, out of the n elements, one element will already be filled in this one, so the remaining elements will be n minus 1 elements will be remaining. So in order to fill the second box, we have n minus 1 options. So after filling this, total 2 elements will already be filled. So for the remaining r minus 2 boxes, we will have n minus 2 options, and so on. When we come until this, we will be left with n minus r plus 1 choices. So after this, the remaining n minus r elements will be left, because we have already chosen the r elements that we want to arrange. Okay, so permutation is nothing but choosing some elements out of the given elements and finding out how many ways we can do like that. Okay, so if we saw the fundamental theorem of counting, there were three works. There were three different ways of doing them: m1, m2, m3. So if we were to do all the works one after the other, the answer, the number of ways of doing them will be m1 into m2 into m3. So if we applied the same principle here, suppose if we considered filling the box 1 to be w1, and if we considered filling the box 2 to be w2, if we considered filling the box 3 to be w3, and so on, if we considered filling the box r to be wr. Okay, so individual ways of doing them are n minus 1, n minus 2, and so on, n minus r plus 1. And we are doing all this one after the other. So we are doing work 1 first, after that we are doing work 2, after that work 3, and so on. So the answer will be n into n minus 1 into n minus 2, and so on, n minus r plus 1. So I hope you understand how this expression comes out. And as it is a multiplication of elements, it can be written as pi k equal to 0 to k equal to r minus 1 n minus k. Okay, suppose there are n elements, right? So given there are n elements, so out of these n elements, we are going to choose r elements. Suppose out of the given n elements, we were to choose 0 elements. So if you think about it in a common way, without applying any formula or something, if you think about it in a common way, there's only one way of not choosing anything. There's only one way in which out of the n elements, you cannot choose any number. If you cannot choose any number, you cannot arrange that number also, because you have chosen nothing. So by convention, by applying general logic, NP0 will be equal to 1, because there is only one chance in which out of n elements you are not choosing anything. Okay, so by convention we can write NP0 equal to 1. Otherwise, if you observe this, all the terms, if we add n minus r, n minus r minus 1, n minus r minus 2, and so on, if we add up to 1, that will lead to n factorial. Out of them, n minus r plus 1, these terms are eliminated. So in the denominator, we have written n minus r factorial, in the numerator n factorial. And n factorial by n minus r factorial will give us this expression. And as we already discussed in the previous class, NPR is a symbol, nothing but NPR denotes out of the n elements, r elements are permutated. So this is what the symbol states. So for this expression, we have given this symbol NPR, and numerically it can be determined by n factorial by n minus r factorial. And in place of r, if we put n, so n minus n will be 0 factorial. 0 factorial is 1. So n factorial will only remain. So npn equal to n factorial and np0 equal to 1. Okay. So I think you understood the basic definition and the basic formula for calculating NPR. Okay. So next we'll solve a simple problem which will even further help you to understand the basic principle of fundamental principle of counting. So they have given us a word equation. So there are 8 unique elements. So n equal to 8, out of which they want us to form 4-letter words. So r equal to 4. So for forming 4-letter words, the answer will be NPR. Okay, that is 8PR. That is 8 factorial by 8 minus 4 factorial. Okay, that is 8 into 7 into 6 into 5. This is nothing but 6 5 is 30, and 37 is 210, and 210 into 8 is 210 into 8, 0, 8, 16, 1680. Okay, so this is how we find by formula. But if we were to find by a normal method, so we are considering 4 empty blocks here, because we want to arrange 4-letter words. Okay. So for filling the first block, we have 8 options. So after filling the first block, we will be left with 7 elements. So for filling the second block, there are 7 elements left. Out of 7, we can choose anything. For filling the third block, out of 6 elements, we can choose anything. For filling the fourth one, out of 5, we can choose anything. So if we apply fundamental principle of counting, it will be nothing but 8 into 7 to 16 to 5, which is nothing but equal to this. Okay. And there's one more condition in the second one. So first one we have solved. 4-letter words will be 1680 words. We can form 1680 unique words. Okay. And the second is beginning with E. Suppose out of the 4-letter words that we want to form, we have already fixed that the first block will be filled with E. Okay. So there's only 3 blocks that is left for us to choose. Okay. So already one element is filled. So out of the remaining 8, out of the available 8, already E is taken. So only 7 elements are remaining for you. So the third block will have 7 options which can be filled. This can be filled in 6 ways. This can be filled in 5. So it's nothing but 210. So there are 210 words. There are 210 4-letter words which begin with E. The same you can apply to ending with N also, because the first 3 blocks are left for us to choose and the last block is decided that we are going to fill n. Okay, so out of these remaining blocks, there are 7 ways to fill this, 6 ways to fill this, 5 ways to fill this. So there are also 210 words, unique words, which are ending with n. Okay, so the final one is begin with E and end with N. So already we have chosen 2 positions in our 4-letter words. The first one will be with E and the second one will be, and the last one will be with N. So already out of the 8 elements, 2 are already chosen. So 6 elements are remaining. So we can fill this one in 6 ways and this one in 5 ways. So 6 5s are 30. There will be 30 unique words, 30 unique 4-letter words, which will be starting with E and ending with N. So this is how we can normally calculate, or you can use formula. So this one will be, we are having 6 elements and there are 2 boxes for us to arrange. So 6p2, that's nothing but 6 factorial by 6 minus 2 factorial. That is 6 factorial by 4 factorial. That is 6 into 5 equal to 30. We can use the formula also, but generally to understand more logically, we can do like this. Okay, we'll move on to the next question. So this I will not solve completely. I'll give you hint. I'll give you the hint. It's similar as the previous problem. So there are total 7 elements. N equal to 7. 1, 2, 3, 4, 5, 6, 7. Okay. Out of which they're asking us to form 4-letter words. So R is equal to 4. And they are giving the constraint that the first letter should be a vowel. So what are vowels and what are consonants? You should know the difference first. Okay. Most of you will be knowing that, but I'll repeat it anyway. So vowels are A, E, I, O, U. Any of these letters can be considered a vowel, and remaining everything in A to Z, remaining everything except these is considered as consonants. Okay, so in the given question, I is a vowel, A is a vowel, and E is a vowel. So there are 3 vowels in the question, I, A, E, and there are consonants M, R, C, L. Okay, so beginning with the vowel, so number of choices for filling the first letter is 3, because there are only 3 vowels in the given set of elements, and remaining you can fill with anything you want. It can be either be a vowel or a consonant. So after filling this first block, out of the total 7 letters, if we fill the first one, 6 elements will be remaining for us. Okay, so this can be filled in 6 ways, this can be filled in 5 ways, this can be filled in 4 ways, because we don't care if the last 3 letters are vowels or consonants. We can fill anything as we like. So total number of words that can be formed like this is 3 into 6 into 5 into 4. 5 4s are 20, 26 are 120, 123 is a 360. Okay, similarly what they're asking is the third one, the second one, what they're asking is it should begin with the vowel and end with the vowel. So if we fill the first one, we are having 3 chances to fill the first one. So one of these will already be filled, so we will be remaining with 2. So this last one has 2 options to fill with. Okay, already now we have filled the first block, we have filled the last letter. So 2 letters are already gone from the given number of elements, 7. So 5 will be remaining. 1 vowel and 4 consonants will be remaining to fill in these 2 empty blocks. So this can be filled in 5 ways, this can be filled in 4 ways. So the total number of words that can be formed using this condition is 3 into 5 into 4 into 2. 5 4s are 20. 20 into 3 60. 62s are 120. So total 120 words can be formed which are beginning and ending with vowels. Okay, so this is the answer for second condition. So remaining ending with consonant, you can do it like that, the similar way. Okay, and the answer for that I'll tell you so that you can verify. The answer for that will be 480. Okay, and Hope you understand it. The next one is, this is one of the important points which can be remembered, because sometimes it's directly being asked as a objective question. So I'm not going to prove it. I'm just going to explain what the statement is so that you can remember the formula. And if any of you are interested in knowing the proof, please please let me know in the comment section. So I'll make a separate video for that. Okay. So it's derangement of things. Nothing but, suppose in the previous question they have given you equation. Okay. So in this, if you look at the order, 1, 2, 3, 4, 5, 6, 7, 8. So E was in the first position, Q was in the second, and so on. All the terms were in the given order. Okay. So when you are arranging these elements or jumbling these elements like this, what the derangement means that nothing should be in its original position. No element should be in original position. Okay. That means all these elements are in a certain position in the given word. Okay. So after arranging them, they should not be in their original position. Suppose consider this: Q, E, A, U, I, T, N, O. Suppose if you consider this, Q was supposed to be in the second position, but it's in first here. E was supposed to be in the first, but it's in second position here. The same. It was supposed to be in fourth, but it's in third. It was supposed to be in third, but it's in fourth. Similarly, they are not in their original position. Though this is one of the example of derangement. So number of derangements that can be possible when n distinct elements are given. Okay. So what they're asking is, how many arrangements can we make that look like this, in which the elements do not occupy their original positions. So the formula for that is n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial and so on, minus 1 whole power n by n factorial. It's an interesting proof. If any of you want it, I'll make a separate video for that, but it should be fair enough or easy to memorize, so that whenever an objective question comes like a derangement of 7 elements, so you can directly apply 1 by 7 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial plus 1 by 6 factorial minus 1 by 7 factorial. So you can solve this, right? Okay. Now next. So this is also one of the important or unique models that's being asked. So sum of all 4-digit numbers that can be formed using the digits 1, 3, 5, 7, 9. So n equal to 5, because there are total 5 elements, and they're asking us to form 4-digit numbers. So if you consider 4 boxes like this, okay. Now what they're asking is, they're asking us to sum all the 4-digit numbers that can be formed. So what they're telling us is, they're telling to permutate. Okay. And how many numbers will we achieve out of this? So there are total 5, n equal to 5. So we wanted 4-digit numbers. So 5p4, this is the total number of numbers that will come out of this permutation. So 5p4 is nothing but 5 factorial by 1 factorial. That's nothing but 5 into 4 into 3 into 2 into 1. 5 4s are 20, 23s are 60, 62s are 120. So total 120 unique numbers will come. So what they want is, they want us to add all these 120 numbers and give them the final output. So how do you approach this problem? And for this, there's one basic thing which you should all know is, What's a unit place? What's a tens place? What's a hundreds place? What's a thousands place? Suppose if anyone's given you some number like 1, 2, 4. So this is units place. This is tens place. This is hundreds place. And if something like 2 is present here, this is thousands place. So nothing but it can be written as 2 into 1000 plus 1 into 100 plus 2 into 10 plus 4 into 1. 4 is being multiplied by units place, that is 1. 2 is being multiplied by tens place, that is 10. 1 is being multiplied by hundreds place, that is 100. And 2 is being multiplied by thousands place, that is 2000. 2 into 1000. So this will be 2000 plus 100 plus 20 plus 4. It's nothing but 2124. Okay, so any number can be written like this. So when you analyze this, there are 4 places and there are 5 elements. So for example, if you consider the units place first, okay, and if you place we have to place one of these elements here. So suppose I am considering 1 in the units place. So out of these remaining 4, we have to choose 3. Okay, there will be 4 P3 combinations where the units place will be 1, right? And suppose you have chosen 3 in the last. Okay, so there will also be the same 3 boxes remaining, and there will be 4 elements remaining from here because we have already chosen 3. So 1, 5, 7, 9 will be remaining, out of which we have to fill 3 boxes. There also 4 P3 chances will be there. So for all these 1, 3, 5, 7, 9, when we place each and every one of this element in the units place, there are 4 P3 unique numbers that are forming, correct? The same goes when in place of in place of units place, if we place these numbers in tens place also. Suppose if we place 1 in the tens place and this is free, this is empty. So now also there are 3 empty places, out of which there are 4 terms. So there also there will be 4 P3 combinations, 4 P3 permutations in which we can arrange the remaining digits. Even the same occurs when we place this in hundreds place. Even the same occurs when we place each of them in thousands place. Okay, hundreds place and thousands place also. So for all these 4 cases, when we place each and every one of them, there will be 4 P3 other combinations, right? So when we are adding all these 120 elements together, so and if we try to represent them something like this, then what will be the answer in this particular case, in this question? It will be nothing but 4P3 into 1 plus 3 plus 5 plus 7 plus 9 into 1 for ones place. And the same will repeat for tens place also. 1 plus 3 plus 5 plus 7 plus 9 into 10. The same will repeat for thousand place also. 4P3 into 1 plus 3 plus 5 plus 7 plus 9 into 100th. The same for thousandth. 3 plus 5 plus 7 plus 9 into 1000. So if you take out the calculator and if you find the value, it will come out to be 6,66,600. Okay. Now there are 2 basic aspects. One, we can write a number like this as an addition of their places into the number which is present at that place, and the idea should be coming that one of these elements can be placed, there will be 4P3 other combination in which the remaining places can be filled. Okay, and then if we add all these elements, these all the 4P3 terms will be repeating, so we can represent it something like this. Okay, I hope you understand. Next, permutations when repetitions are allowed. Okay, so until now, what you are discussing is, suppose if they gave you a word equation. Okay, so suppose there are 4 empty spaces, so that means r equal to 4. We need to form 4-letter words. Okay, so suppose if we filled the first term with e, then we did not repeat e again because we considered that the e is already used in this expression. So what this repetitions are allowed means that, suppose we filled e here, we can also fill e again here. We can also fill e again here. We can also fill e again here. This will also be one of the words, right? Because we have not used anything other than these elements. So they have given these elements. So we'll use them and we can repeat them also. So this is a case when where repetitions are allowed. Okay, suppose they ask you to form any number with the digits 1 3 5 7. So suppose 1111 is a number which is having all the digits 1. So we are not doing something wrong, we are just considering a case where repetitions are allowed. Okay, so in this case, all the boxes which we want to fill will be having n places to choose from, because there's nothing there's nothing like the concept of reducing the numbers. There's nothing like after n there should be n minus 1, because we have already used one of the elements can repeat themselves. So there are n options for every term. So suppose there are r boxes, so there will be n options for each of the r boxes. So using the fundamental theorem of counting, it's nothing but n into n into n into n r times, it's nothing but n power r. So that's what this definition states. When n and r are positive integers, if the repetition of things or elements is allowed, then the number of permutations of n dissimilar things taken r at a time is n power r. So nothing but with at least one repetition, total n power r minus no repetitions is NPR, right? In NPR, there will not be any repetitions. In n power r, all the repetitions will be allowed. So if we subtract NPR from n power r, we'll get a number of terms in which there is at least one repetition. Okay. So suppose if you consider like this is total n power r and this is NPR. Okay. So in the NPR, there is no repetition. So n power r is everything, repetition plus non-repetition, everything n power r, because the repetition is allowed, it's not prohibited in this one. So non-repetition also will be there, repetition also is allowed. But in this NPR, only non-repetitive. So when we subtract n power r from NPR, at least some repetition will be remaining, that is this part. Okay, hope you get it. It's in the form of Venn diagram. Just I'm trying to give you the concept behind it. Okay. Next, there's also one more thing which you should know before we head towards the questions in the next lecture. That is palindrome. So what does a palindrome mean? So palindrome means, suppose if you consider ATTA, if you consider this word, so if we pronounce it from left to right also, it's ATTA, and if we spell it from right to left also, it's ATTA. So it's spelled the same from both right to left and left to right. So these terms are called palindromes. Suppose from the given n elements, we were asked to form r letter palindromes. Okay. So whatever the first element we chose, that will be the last element also, because it's a palindrome. The first and last letters will match. Suppose we choose the second element. The second element from the last also should be that element, and so on. It will happen like that. So in the R letter palindrome, it's enough for us to choose only R by 2 elements, that is half the elements. Remaining half will be automatically chosen. So n power R by 2 is the number of permutations of R letter palindromes when n elements are given. When n are equal to even, when r equal to odd, it's r plus 1 by 2. Because if you consider odd palindromes like robor, okay, it's not an actual word, but let's just consider for the explanation point of view. So in this, you need to choose 1, 2, 3. Three terms you need to choose, because here the b is not repeating, as it has odd number of elements. 1, 2, 3 needs to be chosen, that is r plus 1 by 2, this case. Okay, suppose when you're considering ATTA, then only two elements need to be chosen, the other two will automatically be chosen for the given permutation, right? So r by 2, n power r by 2 is when the r is even case, n power r plus 1 by 2 when r is odd case. I hope you got all the points. These are all important points regarding linear permutation. Okay, in the next lecture we'll solve some previous year questions. Okay, and after that we'll move to circular permutation, right? So please like, share, and subscribe if you like my videos. Recommend it to your friends whom you think it may be useful, and ask them to do the same. Okay, it will really help me, and it takes some effort in recording this lecture. So please support me. Thank you. Hope you look forward for the next lecture. Bye bye.